Hello everyone, welcome to attend our class. Today we are going to study section 6.6, Design Method of fillet welds in China. In this lesson, we will study the basic design equations of fillet welds in section 6.6.1 and the calculation of fillet welds commonly used in China in section 6.6.2. The stress distribution of fillet weld is complex, and it is difficult to calculate accurately. Therefore, simplified calculation method is often used. Test results indicated that the failure of the fillet weld often occur in the weld throat, so the effective thickness of fillet weld HE is picked up, which is along the direction of 45 degrees. And the effective area is the product of the effective thickness and the weld calculation length. The stress applied on the cross-section includes the normal stress perpendicular to the weld, the shear stress perpendicular to the weld length, and the shear stress parallel to the weld length. If the length of fillet weld is too small, it will cause serious local heating of the base material during welding and decrease the quality of the welding. The method of double-sided fillet weld can be adopted for the connection between the splice cover plate and the steel plate. The design of the size of the splice cover plate shall be based on the principle that the bearing capacity of the splice plate shall not be less than the carrying capacity of the main plate, and the total sectional area of the splice plate shall not be less than the sectional area of the connected steel plate. The length of the cover plate shall be determined by the length of the side fillet weld. The side fillet weld is mainly subjected to shear stress with small elastic modulus, low strength, and good plasticity. And the shear force, the shear stress of the side fillet welds is parallel to the length direction of side welds, which must be less than the strength design value of fillet weld, so as to pledge the safety of the weld. The properties of the front fillet weld and the side fillet weld are different. The stress state of the front fillet weld is more complicated than the side fillet weld and the action external force. And the action of shear, three stress, namely sigma vertical, tau vertical, and tau parallel, appear at the front fillet weld. There is a serious stress concentration at the root of the weld. The stress of the front fillet weld is mainly normal stress, so its rigidity is larger. Its static strength is higher. The static failure strength is also higher than the side fillet weld, but the plastic deformation is poor. The fatigue strength is low, therefore it is not suitable to use the front fillet weld for the connection with high fatigue requirements. This formula is used to show the relationship between the three stresses and the weld strength. In practical engineering, the connection between the steel plate and the steel column needs to bear bending moment, and the action of moment, the stress on the effective area of fillet weld is triangular, and the maximum stress is equal to the ratio of moment to section modulus. When the maximum stress is less than the product of beta F and the strength design value of fillet weld, the weld is safe. That's all for this lesson. See you next time.